What's up geeks, and welcome to the channel. In the previous videos of this series, we tackled several problems that concentrate on binary trees, and today is no different. So suppose you are given the binary tree you see in front of you, and imagine yourself standing on the right side of it. What you need to do is return the values of the nodes you can see ordered from top to bottom. In this example, the values returned would be the ones you see in front of you. Now, the first solution that may pop to your mind is start at the root and keep traversing the rightmost node you encounter until we reach a null node. And for the specific example we now have, this solution will work because it is a perfect tree. But what if we had a non-perfect tree like the previous one? By traversing rightmost nodes only, that is the solution we will get. However, what we want is something like this. This is the expected output the interviewer is looking for. So the best way to tackle such a problem is retrieve the levels that constitute this tree and add the last node of each level to the result list we will be returning. The level order traversal of a binary tree is implemented with the help of queues. We previously discussed in detail every aspect of this implementation in the video linked in the card above. So after we initialize our queue and add the root node to it, we need to loop over each level individually and add the next level to the queue, which basically consists of the left and right nodes in a binary tree. We will iterate over the queue and repeat the same logic until there are no nodes left in that queue. Now to tackle our current problem. With every level being traversed, we need to check if the node we are currently processing is the last node of that level. If that is the case, we add it to our result, and after going through all the nodes, the resulting list will be complete. And that's it. The beauty of this solution is that if you wanted to retrieve the left side view, all you must do is check if the node at hand is the first node of this level instead of being the last. Okay, after solving this problem, the interviewer might choose to scale things up and modify the node we are currently making use of by adding a next pointer to it. What we need to do now is make use of the same level traversal technique to populate each next pointer to point to its next right node. If there is no next right node, the next pointer should be set to null. Notice the levels we have in this example. As you can see, each level represents one internal iteration in the queue we previously had. And with every iteration, the nodes present inside each level will also be inside the queue. So the next pointer of node 3, let's say, will be populated with the next node in the same level, or in other terms, the next node inside the queue at that moment, which in this example is node 4. You see, as soon as you figure out the level traversal implementation, all these problems become a matter of modifying the single line of code we added that generates the answer. Therefore, let's get rid of everything specifically related to our previous problem, which are basically the line we were talking about and the result list, and keep the core implementation of the level traversal technique. In this problem, we will be receiving the root node as input, and our output will also be that root node, but the difference is that the nodes of the tree referenced by the returned root will have their next pointers populated. To retrieve and populate the next nodes from the queue without removing them, we can make use of the peek method, meaning if the node of our current level is the last node of that level, then it should point to null, and if not, it should point to the node we peeked at. And that's it. By modifying a single line of code, we were able to solve two different problems. Okay, the last modification that can be done by the interviewer to this problem is guarantee that the tree you will be given will always be a perfect tree. As a reminder, a perfect tree is a tree where all leaves are on the same level and every parent has 2 children. You see, the implementation we just wrote works even if the tree is perfect, so this new problem is already solved. But how can we make use of this information to further optimize our solution? Well, think about it. If a tree is perfect, then the next pointer of all left nodes of this tree will always be populated with their sibling right node, as it will always exist. And the next pointer of right nodes will either be populated with null if it is the last node of the level, or it will be populated with the left child of the next pointer of its parent, as it is the case with node 4 in this example. What we just said can be represented by the if conditions you see in front of you. Now these conditions should be applied on all the nodes of the tree, and the easiest approach to do this is by applying recursion. This way we will be able to traverse all the nodes in the tree, and that's it. We managed to solve this new problem in place without creating an extra queue. The links to the LeetCode problems we solved today can be found in the description below. Let me know your thoughts and suggestions for upcoming videos in the comments section. And that's it for today. I hope it was helpful. Thank you guys for watching, take care, and I will see you in the next one.